All right, Algebra 1. Test review, test 21. This is the last test of the year. I think we can do it. Let's figure it out.
Flack math! Give me some math and I'll give you some flack. Flack math!
All right, number 1. Let's do it. When the piggy bank was opened, it yielded $5.22 in nickels and pennies. Ooh. If there were 162 nickels and pennies altogether, how many of each were in the bank? Okay, so this is a value and quantity problem, all right? So let's figure out our quantity problem first. Let's see, 162 nickels and pennies, okay? How do you say that? Well, you don't know how many of each we had, so I'm gonna say N stands for nickels, number of nickels, and P stands for number of pennies. Altogether, the total number of coins is 162. Now, this does not tell you how much money you have, okay? It just tells you how many coins you have. Well, now how do you figure out how much money you have? Well, you count your number of nickels and you multiply it by 5, right? So 5 times your number of nickels plus 1 times your number of pennies, because every single penny is worth a cent. So you could say 1p or just p is fine. And what does that equal? Well, we're in cents now, so 522 cents. Okay, that's cool. All right, so now you can solve this either by elimination or substitution. You could even do graphing if you want. I'm gonna just do elimination, because look what happens if I do elimination. If I just negate everything, then I can just add them together and I get 4n plus nothing equals 360. Okay, cool. Solve for n, divide by 4, divide by 4. N equals 90. So if there are 90 nickels, how do you figure out how many pennies you have? Well, if there's 162 altogether, the number of pennies is gonna be 162 minus 90. So pennies equals, let's see, 72. All right, count up that money, see if you get $5.22. 90 nickels is $4.50 plus 72 cents is $5.22. That works. This is elimination. We could have solved this by substitution. So let's do it another way where we're solving by substitution, just so you have 2 options when you take the test. All right, we still have our same equations. I'm not gonna say 1p because 1p is just p. All right. I'm going to rewrite this guy as, I'm just gonna get n by itself, or yeah, n equals 162 minus p. All I did was subtract p from both sides to get n by itself. Okay, now I can plug that in for n. So I get 5 times n, which is 162 minus p, plus p equals 522. All right, let's see, 162 times 5 is 10, 31, 810 minus 5p plus p equals 522. All right, first step to solving equations, we just did that. We distributed by simplifying both sides separately. The second step of simplifying both sides separately is to combine like terms. So 810, this is a negative 5p. If you don't know that, just chicken scratch. So minus 4p or plus negative 5p or negative 4p equals 522. All right, now get rid of that 810. So negative 4p equals, all right, we have to subtract. 810's bigger. 288. And that's negative because 810's bigger. Now divide both sides by 4. Or actually negative 4, and the negatives cancel. So P equals 72. All right, so if P equals 72, how do you figure out what N is? N equals 162 minus 72, which is 90. Okay, so 2 different options to do that. All right, so let's do number 2. Okay, number 2, find 4 consecutive odd integers. All right, a lot of you struggled with this on the last test. So 4 consecutive odd integers. We're going to have a first one, a second one, a third one, and a fourth one. Okay, the first one we're going to have be n. Well, how do you get from the first odd integer to the next odd integer? Well, in between like 3 and 5 is just 2. In between 5 and 7, it's just 2. In between 7 and 9. So you're just adding 2 to get to the next odd integer. Consecutive means one after the other. So the next odd integer is n plus 2. And then you're adding 2 more to that, and that's n plus 4. Adding 2 more to that, and that's n plus 6. So now you have your key. So now when you translate, you know how to translate it. Okay, so here's my translation. 5 times the number. So how do you say 5 times something? Well, that's going to be 5 times a parenthesis. So we don't know what it is yet. It is the sum of the first and the third. Okay, so how do you say the sum? Well, that's addition. The first is n, and the third is n plus 4. See where I got that? Okay. So then it says, is 15 more than, okay, is 15 more than. If it was less than, then you'd have to put it on the other side, so minus 15, but 15 more than what? Well, 5 times the fourth. Well, how do you say 5 times the fourth? 5 times, what's the fourth? N plus 6. Okay? So, look at it again. 5 times the sum of the first and third is 15 more than 5 times the fourth. All right, now we have our equation. Simplify and solve. First step to solving the equation, simplify both sides separately. So we're gonna do that. You could combine in here if you want first, but let's just distribute. So we get 5n plus another 5n plus 20 equals 15 plus, distribute that, 5n plus 30. All right, second step to simplifying both sides, combine like terms on both sides separately. So 5n and 5n becomes a 10n. And then 5n doesn't combine, but 15 and 30 combines to 45. All right. Second step to solving equations, get rid of smaller variable term. If you have variables on both sides, you do. You have a 10n and 5n. So get rid of 5n. To get rid of a term, you either add or subtract it. If it's being added, you subtract it. If it's being subtracted, you add it. Okay, so now you have 5n plus 20 equals 45. Third step to solving equations is get rid of constant on variable sides. So that's what we're going to do here. So now we're left with 5n equals 25. Last step, solving equations, divide by variable's coefficient. So n equals 5. So this is not your answer. This is just you just solved the equation. The answer, you have to answer the question. Find 4 consecutive odd integers. Well, remember this is the first one. So what are the 4? 5, add 2, 7, add 4, 9, and 11. Okay, that's not too bad, right? All right, number 3. Only 3/8 of the students wanted to become math teachers. Seems kind of low. If 3,500 did not want to become math teachers, how many university students were there? So this 3/8 of the university students wanted to become, so let's make that be our equal. So 3/8 of the students wanted to become math teachers. Okay? Well, then it says 3,500 did not want. Okay, so what fraction is that? So we can say that 3,500 is 5/8. You see how we got that? Well, if 3/8 wanted to become, then 5/8 did not want to become. Okay? 3,500 is 5/8 of the students, right? This is an equation. Let's translate that. 3,500 equals 5/8 of S. All right, so let's figure out what S is. How do you get S by itself? You divide by 5/8 on both sides because that's what's being multiplied. It's being multiplied. So then we are left with S equals this division problem, 3,500 divided by 5/8. Okay, how do you divide fractions? Copy dot flop. 3,500 dot flop. Cross cancel because it's awesome. 700. So what do we get when we multiply across? 5,600 students. Okay, cool. All right, number 4. The velvet bag contains 13 gold coins and 5 silver coins. A coin is randomly drawn from the bag and not replaced. Then a second coin is randomly drawn. What is the probability that both coins are gold? Okay, probability. Remember, probability is number of what you're looking for. So how many things you're looking for. That's the total out of number of total stuff or options. Okay. Well, let's see. We are looking for both gold coins, a G, then a G. And this is without replacement. So the second draw is going to be different. You're going to have less coins in the bag and one less gold coin. So let's see what that is. How many gold coins and how many total? There's 13 out of a total of 13 plus 5 is 18. So that's the first draw. Remember, when you are trying to find the probability of 2 independent events happening, it's just the product of those single events happening. So probability of G times probability of G. Okay? All right, now you didn't replace it. So how many gold coins are now in the bag? 1 less gold coin. So now you have 12 gold coins. And how many total coins are left in the bag? Well, 1 less total coin. So this is your multiplication problem. We can do this. Let's do some cross reducing. 6 goes into both of those, 2 and 3 times, so you get 26 51sts. Okay, that's it. That's the probability. Not bad. Okay, I'm making this a little smaller here. We are going to indicate whether these are functions or not. So remember that in order for a function to be a function, all the x's can only go to one y. Okay, so you can have multiple x's for the same y, but you can't have multiple y's for the same x's. Okay, so you remember the domain are the x's and the range are the y's. Okay, so that's probably a better way to think about it. So 4 goes to A and nothing else. 7 goes to B and nothing else. 9 goes to C and nothing else. So 5A is a yes. Okay. What about 5B? Well, M goes to 3 and it goes to 4. No. B is a no. Okay? All right, well, X goes to 2 and Y goes to 2, so that's okay, but Y goes to 2 and it goes to 3, so no. C is not. It could have been if Y didn't go to both 2 and 3, because X going to 2 and Y going to 2 is okay, but Y going to 2 and going to 3 is naughty. All right, so 0 goes to 0. Let's see if 0 goes to anything else. It also goes to -1. So pooey on you. That's a no. -2 goes to 1. Does it go to anything else over it? Okay, no. 2 goes to -1. Does it go into anything else? No. 1 goes to 3, and 3 goes to -4. So all these guys go to separate things. So this is a yes. All right, so the only functions are A and E. All right, number 6. If f of x equals x squared plus 2x plus 2, find f of m minus 1. So all you're doing is plugging this in for x, okay? It's going there and it's going there. So let's just ignore that because that's going to be confusing. So all we're doing is plugging it in. So m minus 1 squared plus 2 times m minus 1 plus 2. See how we did that? So that x is right there, and this x is right there, okay? This is still x squared plus 2x plus 1. So instead of x, we're writing m minus 1. m minus 1 squared is just m minus 1 times itself. So we're going to have to FOIL that sucker out. So that's m squared minus 1m minus 1m plus 1, because -1 times -1 is +1. And then we're going to distribute this out. So that's 2m, and 2 times -1 is -2. And then we're going to add 2 at the end. All right, let's simplify that. So there's no other m squared, so m squared. All right, now look at all these m's. So we got -1m and another -1m. So that's -2m so far. Combined with the positive m, those guys cancel. All right, and then look at this. This -2 and this +2 cancel. So we're just left with a +1. So there's our answer to number 6. All right, number 7. All we're doing is figuring out what we can put into that function that won't break it, okay? So what will break this function? Well, what's the only thing you can't take the square root of? Well, you can't take the square root of negative numbers. Then you would have an imaginary solution. We're looking for real solutions, okay? So what x will make this negative? Well, what do you subtract from 3 to make it negative? So 3 minus 3 is 0, but 3 minus 4 is -1. So that would end up with a negative in the radical. But really anything over 3 would break it. Okay, so 3 minus 3.00000001 would be a -0.99, whatever. Okay, so what we want to do is we want to say the domain is x has to be less than or equal to 3. Okay, it can be 3 because you can take the square root of 0, you just can't take the square root of any negative numbers. So if x is less than or equal to 3, then this function will be fine. And then your domain is all real numbers. Okay, and that's usually going to be your range. All right, number 8. Number 8 says solve by graphing. So we can do that. All right. So first, before we do that, we're going to determine how to graph this, okay? We have to figure out our slope and our intercept. Remember, our slope is what the x is being multiplied by, right? So what is x being multiplied by? It's just 1. So this is 1 over 1. Remember, we want a fraction slope. Okay, this is our slope in this one. Well, what is that being multiplied by? 3, or 3 over 1, okay? And then we want our y-intercept. So our y-intercept is -2, so that's where we can start on our graph at y equals -2. And then over here, we don't have a y-intercept, or in other words, it's +0. So this is our y-intercept for this equation, okay? So let's rewrite the equation up here on our graph. Okay, there's our blue equation, and here's our green equation. All right, so our green equation, I'm going to start with the y-intercept of 0, so that's where that is. And then our slope is rise over run. So it goes up 3 over 1, up 3 over 1, up 3 over 1, up 3 over 1. Okay, so this is what our green equation looks like. Pretty cool. All right, let's try our blue equation. So that starts down here at -2, because that's the y-axis intercept, and then it goes up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Okay, let's draw that equation. And look where that intersects. All right, so now we have solved this. Okay, so what point is that? Well, that is just -1, -3. It goes left 1, down 3. So this, remember, when you're plotting points, it's the opposite of calculating slope, which is rise over run. All right. Now, if you are struggling with that and you want to just use substitution, you could do that. So if y equals 3x, you could just plug that in for y. So 3x equals x minus 2. Get rid of x, get rid of x. 2x equals negative 2. So divide by 2, x equals negative 1. So if x equals negative 1, y equals negative 3. So you could do that if you wanted to, but you might as well graph it. And I'll tell you what, if you graph it and you show me by graphing that the solution is that solution, then I'll give you extra credit. Boom. All right, number 9 says solve by elimination. And I don't think you want to solve it by anything else because then you'd have fractions. So elimination means if you add the two equations, your goal is to add the two equations and it would eliminate a variable because you would be adding opposites. Well, we don't have any opposites, but we can find a common ground. If you add 3 and 4 together, it doesn't work. Even if you make this negative, all this negative, and you add it together, you still wouldn't cancel. It'd be close, but it wouldn't cancel. So what can you multiply by this and or this to make it so when you add them together, they'll cancel? Well, let's try this. Let's try multiplying this top equation by negative 4. Okay, whatever you do to one side, do to the other. That's okay. So if I do that, let's just do it over here. So that equals negative 12x minus 8y equals positive 48. See what I did? I just multiplied both sides by negative 4. Same equation, just a little chubbier. All right, let's do this. Well, what can I multiply this by? I'm going to multiply this by 3. Okay, when I do that, I get positive 12x. Ding, ding, ding. 3 times 5y is 15y. And negative 23 times 3 is negative 69. So now when I add them together, look what happens. I get, these cancel, and I get negative 8y plus 15y is 7y. And then 48 plus negative 69 is negative 21. So now when I divide by 7, I get y equals negative 3. All right, so you're half done. So now what I'm going to do is I'm going to plug this into either one of these equations. I'm going to plug it into the top one. So I get 3x plus 2 times y, which now we know is negative 3, equals negative 12. All right, so this is 3x plus negative 6 equals negative 12. All right, third step to solving an equation is get rid of constant on the variable side. So that's what we're doing. So we get 3x equals negative 6. So now we're going to divide by variable's coefficient. X equals negative 2. Okay, so far, I feel like that's the right answer, but here's how you check to make sure. You just plugged it into the top equation. Let's plug both of these into the bottom equation and see if it works. 4x, well, what's x? Negative 2, so that's negative 8. 5y, what's y? Negative 3, so that's negative 15. So what's negative 8 plus negative 15? Negative 23. It works in both equations, so you're good. All right, number 10. And we're gonna stop here and we're gonna do the rest on Thursday. So this will be the last question for this video, okay? So given RATA plus RBTP equals 150, RA equals blah, blah, blah. All right, so what we're gonna do is we're just gonna plug in what we know here. So RA is 2, so that's what we're gonna plug in for RA. RB is 4, so we're going to plug in 4 when we see RB. And then TA equals this guy. So this is just, it's not a number, but we can plug it in for TA because TA equals TB plus 3. So we're going to plug this in right there. All right, let's rewrite this equation. This is like our mother equation, and we're replacing it with values that we know. All right, so RA is 2. TA is TB plus 3. Don't forget parentheses, because otherwise you'd just be multiplying 2 times TB. You want to multiply it by all of TA. Plus RB, which is 4. And TB we don't know. We don't have something that says TB, so we're just gonna leave it. Equals 150. All we did was rewrite that equation. All right, first step to simplifying is distribute, get rid of parentheses. So 2TB plus 6 plus 4TB equals 150. Second step to simplifying both sides separately is combine like terms. We have 2 TBs. So that's 6 TBs. Plus 6 equals 150. All right. Second step to solving equations is if you have variables on both sides, get rid of the smaller one. You don't. So we're skipping to step 3, which is get rid of constant on the variable side. So 6 TB equals 144. Last step, divide by variable's coefficient. So we get TB equals 24. All right, so if TB equals 24, then we can plug it in right there to get our TA. TA equals whatever TB is plus 3. So TA equals 27. Awesome. All right, let's plug it into our main equation, see if it works. RA is 2, our TA is 27, 2 times 27 is 54. RB is 4, TB is 24, 4 times 24 is, 96. So 96 plus 54 is 150. That works. Okay, cool. We did it. All right, so that's 1 through 10 on test 21. We're gonna do 11 through 20 in the next video, so stay tuned.
Black